All right, so before I start, remember there's a quiz tomorrow. So let's see, that'll include the stuff we did last week. So we did a couple things last week. We talked about lengths of segments in a circle. Okay, so that included when you have a circle with two chords intersecting inside. Remember, the formula is the product of the segments of one chord equals the product of the segments of the other. So like A times B equals C. Does that make sense? Then we did another formula that related to combinations of secants and tangents. So if you have two secants, this, remember the formula is the whole secant times just the outside part equals this whole secant, just the outside part. And if you have a secant and a tangent, like this, the formula is the whole secant times the outside part equals the tangent squared. Okay? So that's what we did there. Then we also talked about constructions, constructing the tangent line to a circle. Remember, it's the same basic construction as constructing a perpendicular bisector. There was one other thing. What was that? It was equation of a circle. Just if they give you a picture of a circle, you have to be able to give its equation. Okay? Any questions on that stuff? Yeah, sure. So if this is A and B and C and D, this formula is A times B equals C times D. If this is A, B, C, D, then this formula is the whole secant, A plus B, times the outside part, B, equals this whole secant, C plus D, times the outside part. And if this is labeled like A, B, and C, then the whole secant, B plus C, times the outside part, C, equals A squared. You're welcome. So then we also did the construction of the tangent line, and finally the equation of a circle, which we've been talking about the last couple of days. Any questions on that? So there won't be a lesson tomorrow, like a normal lesson. There won't be a recorded lesson or anything like that. Just make sure you take the Delta math quiz. You guys will be here, but if anybody's watching, make sure you take the Delta math quiz before 8 p.m. Okay? Right. So today we're going to sort of go off on a little sidebar. What? It's a side class, if you will. So suppose you have a quadratic equation. So this is just a quadratic equation. So today's stuff is going to seem unrelated, but it'll tie back in next time we meet. So suppose you have a quadratic equation like something like x squared plus 6x plus 8 equals 0. So if you remember from algebra class, there's a couple different ways to solve this. One way to solve this, you probably learned maybe like 4 ways to solve this. There's lots of ways to solve this, but you've probably seen like 4 ways to solve this. 4 main ways to solve this. The first way is graphically. Which means you graph the equation y equals x squared plus 6x plus 8, and then you just determine where it crosses the x-axis, which is just to say when it equals 0, right? So you just graph this and determine where it crosses the x-axis. Okay? The problem with this method is it's very time consuming. It requires sort of like neatness and precision. And even then, maybe the place where it crosses the x-axis aren't whole numbers. Maybe it crosses the x-axis at 2/3 or at the square root of 7 or something weird, right? So it's really hard to figure out what those points are on a piece of graph paper, okay? Whole numbers, it's kind of easy to tell where it crosses, but if it's not a whole number, this is not very convenient. What does the graph of something of this form look like? What? You're whispering.
I said that's a good question.
That is a good question. Thank you. What does the graph of a quadratic equation look like?
Does the x squared really change?
Definitely does. So like y equals mx plus b, that's called a linear equation because it's a line, right? Anything of this form, it's called a quadratic equation. It looks like a parabola. Learn that, right? A parabola, either opening upward or opening downward. How can you tell if this one opens upward or downward?
Positive or negative?
Yeah, if the x squared term, if the coefficient of x squared is positive, then it opens upward. Coefficient of x squared is negative, then it opens downward. So we would know that this graph maybe looks something like this, okay? And we would just want to figure out where it crosses the x-axis. But again, like I said, this is not super practical. It's very time consuming. It's a lot of work, and it's not very precise, okay? So you don't do that way very often, but it's a method, so I just wanted to include it. The second way that you can do this, called this equation, is by factoring. I know you did this last year. So if you have something like x squared plus 6x plus 8 equals 0, remember the steps to solve this by factoring are, first put it in standard form, which this is. Standard form is just everything on one side, like terms combined, 0 on the right, right? And then you factor. So if you remember how that works, you break it up into two binomials that both start with x, and you try and find two numbers that multiply to give you 8 and add to give you 6. So what numbers would work here? They multiply to give you 8 and add to give you 6. 4 and 2. So this would be like x plus 4, x plus 2. This is all familiar to you, right? Then, if you have something plus something or times something equals 0, that means either this is 0 or that's 0. There's no way you can multiply two things together and get 0 if one of them isn't 0 to begin with, right? You can't multiply two non-zero things and suddenly you get 0 as a product. It's impossible. So that means either x plus 4 equals 0 or x plus 2 equals 0. And these equations are really easy to solve. They're just little linear equations. So you have x equals -4 or x equals -2. Those are the two answers to this equation, the two solutions. Familiar? Should be. Okay, good. That's the second method that you learned how to solve quadratic equations. The third method was quadratic formula. Because again, maybe it's not factorable. Maybe you can't find two numbers that multiply to give you this and add to give you that. That's possible. You could have a quadratic that's not factorable. And that just corresponds to the situation in which the answers that you're going to get aren't going to be like whole numbers or even rational numbers. Maybe they'll be like square root of 7 or something weird. So the factoring method won't work if it's not factorable, right? Doesn't work all the time. It's probably the best way to do it if it does factor, but sometimes it doesn't factor. So then you have this other method, the quadratic formula. Does anybody remember the quadratic formula? Why not? be shy. Go ahead. What is it?
No, it's all right. I just realized.
Does anybody remember the quadratic formula? I'll give you extra credit right now if you know the quadratic formula, including if you're listening at home.
Give me a hint.
I'm not going to give you a hint.
Give me a hint. Right.
I'll give you a hint. You learned it last year. Yes.
Oh, no.
3,
What?
2, 1. You won't even have to take the next test if you know it right now. 3,
I don't know.
It's
Two.
just the same thing as what you have.
1. No. Okay. Nobody knows it. If you have a quadratic equation like ax squared plus bx plus c equals 0, then the equation, the solution is negative b plus or minus square root b squared minus 4ac over 2a.
We didn't know. Yeah, we probably.
You definitely learned
We
this.
definitely did.
Mr. Kelly sang it. He said
I have no
x
idea what that
equals
is.
negative b plus or minus the square root b squared minus 4ac
happened before that.
over 2. Huh?
Must COVID happened before you got that.
No, you definitely learned this. This is definitely an algebra curriculum.
We definitely did learn that, but I didn't.
Of course.
Okay.
So if you have an equation like x squared plus 6x plus 8 equals 0, that means a is 1, b is 6, c is 8. So x equals negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 8 over 2 times 1. I just substituted all the a's, b's, and c's in where they go.
I can't.
You can do it.
The paper art.
So this is negative 6 plus or minus. If I look at all the stuff that's in the radical, I have 36 minus 32, which is 4. So this is negative 6 plus or minus 2 over 2. So if I take negative 6 plus 2, I get negative 4 divided by 2. And if I take negative 6 minus 2, I get negative 8 divided by 2. So I get the same two answers that I got by factoring. Remember, by factoring, I got negative 4 and negative 2. I get the same two answers here. The benefit of doing it this way is even though it's a little more calculations up here, it works every single time. It gives you the answer. Even if the answers end up being irrational or fractions or something weird. It works every single time. Any questions so far? I've said up here there's 4 ways to solve it. So we have graphically, factoring, quadratic formula,
What's that?
and the 4th one is the one I'm going to focus on today, which is completing the square. Which you also learned last year. Okay, so if you have something like x squared plus 6x plus 8 equals 0, here's the step-by-step process. I'm going to pretend like you've never seen it before, but you have. Step 1 is to keep the x terms on the left and put the constant, the number without an x, on the right. Okay, so I'm going to take the 8 and just move it over in this case. X squared plus 6x equals negative 8. That's step 1. Step 2, this is the key step. You're going to add the square of 1/2 the coefficient of x to both sides. That's the key step in completing the square. So I'm going to rewrite what I wrote above. X squared plus 6x. I'm going to leave some space this time, equals -8. And I'm going to follow the directions. It says add the square of half the coefficient of x. What's the coefficient of x in this equation? 6. What's half of that? 3. So I'm going to add 3 squared to this side, and I'm going to add 3 squared to this side. Whatever you do to one side of the equation, you have to do the same thing to the other side of the equation, right? Step 3 is to factor the left and simplify the right. So if you look at what we have on the left, it's x squared plus 6x plus 9. Two numbers that multiply to give you 9 and add to give you 6 are 3 and 3, right? So this is going to factor as x plus 3 times x plus 3, which is really x plus 3 squared. Now, just by the way we pick this number, this half the coefficient of x and then squared, by the way we pick that number, it's always going to factor the same way. It's always going to be whatever this is goes here, and whatever this is goes here every time. Just by the way you pick those numbers, that's always the way it's going to factor. And then on the right, you have -8 plus 9, which is 1. Everybody understand so far? Step 4 is to square root both sides. And don't forget plus or a minus. When I square root both sides here, the square goes away, so I get x plus 3, but on the right I get plus or minus 1. When I square root 1, I get plus or minus 1. Because think about it, if something squared is 1, that means that that stuff in parentheses could have been 1 or it could have been -1. Both of those numbers, when you square them, you get 1, right? If this number happened to be 4, right, then this number in parentheses could be plus or minus 2. If this number happened to be 9, then the stuff in parentheses could have been plus or minus 3, and so on, right? So you can't forget the plus or minus. There's 2 possibilities in every case. Now you just solve for x. Step 5 is solve for x. So I get x equals, if I subtract 3 from both sides, I get -3 plus or minus 1. So -3 plus 1 is -2, and -3 minus 1 is -4. So I get those 2 solutions. Same 2 answers I got by factoring, same 2 answers I got by the quadratic formula, same 2 answers I would have gotten by graphing if I had completed that process. Do you remember doing this process, completing the square? You did. You definitely did. Do you remember?
I do. I don't know.
Shh, don't tell them. I know you did it. So. All right, let's do another example. And if you don't remember doing it, you just have to learn it over again in the next day. So it's better if you remember how to do it. How about this? What if you have x squared minus 12x plus 11 equals 0? Let's do the same process. So I'm going to move the 11 over to the right-hand side. So this would be x squared minus 12x. Leave a little bit of space equals -11. Now I'm going to complete the square. So I'm going to take half of -12. What's half of -12? negative 6. And I'm going to add negative 6 squared to both sides. Now, the reason why I left it as negative 6 squared and I didn't write plus 36 is because the next step is to factor, and I know it's going to be whatever is here plus whatever is here. It's going to be x minus 6 squared. So you can see, if I had accidentally written plus 36, which isn't wrong, but if I had written plus 36, I might forget that this is actually a negative here, not a positive. It's whatever half the coefficient of x is goes in this number. Okay, and then on the right, I have negative 11 plus 36, which is 25. Square root both sides. X minus 6 equals plus or minus 5. And add 6 to both sides. X equals 6 plus or minus 5. So there's two answers. 6 plus 5, which is 11. 6 minus 5, which is 1. Those are the two answers. Let's do another one. How about x squared plus 14x minus 15 equals 0. I'm going to move the 15 over. X squared plus 14x, leave some space, equals 15. What am I going to add to both sides this time? Yeah, I'm going to add 7 squared to this side, and I'm going to add 7 squared to this side. What does the left-hand side become when you factor it? X plus 7 squared. On the right, I have 15 plus 49. 15 plus 49 is 64. Square root both sides. X plus 7 equals plus or minus 8. So x equals negative 7 plus or minus 8. Negative 7 plus 8 is 1. Negative 7 minus 8 is negative 15. Now, one thing that I've done in all these problems so far is I've sort of rigged them to work out nicely because I picked an even number in the middle. But even if there's an odd number in the middle, this process still works. Okay, let me show you. Like if I have an odd number in the middle, like suppose it was x squared plus 7x plus 10. Move the 10 over, so x squared plus 7x equals negative 10. So half of 7 is 7 halves. So I'm going to add 7 halves squared to both sides. You could, but I think it's easier to square 7 over 2 than it is to square 3.5. The square of 7 over 2 is 49 over 4. But the square of 3.5, I don't know, I'd have to do that on a calculator. That's why I keep it as a fraction. Then on the left, I have x plus 7 halves squared. And let's think about what we have on the right. On the right, this stuff is really negative 40 fourths plus 49 fourths, which is 9 fourths, right? You need a common denominator to add fractions. So the right-hand side is 9 fourths. Everybody cool with that? What do I get when I square root 9 fourths? What do you get when you square root 9? No, square root 3. What do you get when you square 4?
Square root, not square.
3 halves, it's 3 halves, right? You just square the top, square root the top and square root the bottom. So this is gonna be x plus 7 halves equals plus or minus 3 halves. So x equals negative 7 halves plus or minus 3 halves. So negative 7 plus 3 is negative 4 halves, which is negative 2. And negative 7 minus 3 is negative 10 halves, which is negative 5. So those are the two answers, negative 2 and negative 5. Let's do one more. How about this one? X squared plus 3x minus 18. So x squared plus 3x equals 18. I'm going to add 3 halves squared to both sides. Again, you can use your calculator. You can do 1.5 squared and just use your calculator the whole way. I think that's more work, but you. And then on the left, you get x plus 3 halves squared equals, on the right here, same deal as before. This is really 9/4. So I need fourths, right? So if I take 18 times 4, I get 72. This is 72 fourths plus 9/4, which is 81 fourths. What's the square root of that? 9 halves. So this is x plus 3 halves equals plus or minus 9 halves. So x equals negative 3 halves plus or minus 9 halves. So negative 3 plus 9 would be 6. 6 halves is 3. And negative 3 minus 9 is negative 12. Negative 12 halves is negative 6. Any questions on that process? That's completing the square. Okay? That's all I got. So on Delta Math, it's just called completing the square. And then don't forget about tomorrow's quiz. Okay?